Okay, welcome to Friday. Go ahead and get out your homework. It was that worksheet 11-7B. All right, we were solving equations, two-step equations involving positive and negative integers. Here are the answers to all 10 questions. Check your answers to mine and answer question 1 on the Google Forms, please. Okay. All right, we've made it. Last class of the year. Now, obviously, we're still going to do a review next week, and then you have your semester finals. But this is the last of the new material. The next time you learn something new in math, it's going to be in course 2 next year. Okay. Just remember, I'm going to review on Monday and Wednesday, and you will not take your math final until that following Thursday. Look at the calendar, please. So how do you do well on the semester final? Remember, I'm going to give you a practice test. We'll do that both on Monday and Wednesday. I'll give you half of it on Monday, the other half on Wednesday, and that will be a duplicate of what is on the actual semester final. So if you can do the practice test, you can certainly do the final. So you have a long time. You have 7 days in between when I give you that last practice on Wednesday until your final to email me and, hey, I need help on doing, whatever it is you're having problems on. Don't wait until that Wednesday afternoon because it's probably too late for me to give you some help then. So make sure you look it over. Secondly, how do you study for finals? Well, obviously, let's just say it's the Memorial Day, the day before your science final, you should definitely be studying for your science final. I would recommend that for all your other ones, you just do a really brief review each day. So remember, you got the whole day to study. So certainly you don't need to study the entire day, but I would do 10, 15 minutes on every subject that you're going to have a final on, and then the night before or the day before your final. For a specific subject, that's what you spend a good solid hour to 2 hours working on whatever your teacher gives you as preparation for your final. That's how I would do it. Okay. And like I said, I don't pull any punches. The final that I give you will be exact duplicate of the practice test. It'll just be different numbers, obviously, but same types of problems. Okay, copy down your last homework of the year. So we're going to end on a very important note. Some of you may have done this before, some of you may not have done this before. This is going to be a foundational piece of knowledge that it's going to be a requirement for you to do well in course 2 in pre-algebra and then further. Today is going to be graphing ordered pairs. So if you guys already know how to do this, it's pretty basic. I'm not going to show you anything dramatically different than what another teacher has shown you. So it might be a review for some of you, but for others of you, could be brand new. What is this thing called an ordered pair, and how do I graph it? And like I said, just like abstract multiply and divide with positive and negative numbers, integers is really important. This is also important as we go forward. Okay, so here's the basic problem. Where are you? And that question of where are you is what we're going to answer today. And we're going to give you an answer, a mathematical answer, not, well, I'm here in the classroom or here in my bedroom or I'm here in the living room type thing. I'm going to give you a mathematical answer to where am I? So this question of where are you, your location, is something that literally stumped mathematicians for, I mean, almost 1,000 years since they started thinking deeply about math. The person who solved it, a guy named Rene Descartes, Frenchman, somewhere in the middle of the 17th century, right around 1620 or 1630, if I recall right, he came up with this idea of how to answer the question of, well, where am I? And when you see it, I know this is one of the few things that always stumps me, which is, why didn't anyone come up with this idea before him? All right, it's a great system, but it's a really easy system. You would think that someone would have figured this out long before the 17th century. When you study high school geometry, which all of you will, you're going to take a course that has changed almost zero from when it was first taught in 200 100 BC. I mean, the geometry that you learned way back then is basically the same geometry that we teach in high school. Nothing much has dramatically changed. But what I'm about to teach you does change. And by the way, the Greeks didn't have this when they did their geometry, nor did the Egyptians. nor did the Chinese, all the Indians, all the great powers of of mathematicians didn't have this until Rene Descartes came up with this. So this is what he came up with. It's a grid. And if you notice, there's a bunch of numbers there, and my job today is to explain to you what all this means and how does this help you answer the question of where am I? So, for instance, that red dot, where is the red dot? This system, this grid answers the question of where is that red dot. And the nice thing, it's a mathematical answer. And the nice thing about it is it's what we call is transportable, meaning that you can take this answer, you can stick it in your pocket, and you can walk anywhere you want in the world, pull it out, and replace that red dot in exactly the same spot every single time. And why is that important? Well, and this is also the foundation of why your television or your cell phone screen actually works. There's a grid, and it places data or information in a specific spot at a specific time, and that's where we get our pictures from. Now, Rene Descartes wasn't thinking about cell phones when he made this. He was just simply trying to answer the question mathematically of where is the red dot. His system is based upon a central point, right? It's dead smack in the middle, and basically how far is the red dot from the black dot. Okay, so let's get into the mechanics of it. So the coordinate plane is made up of two number lines, a horizontal number line. Hey, there's a horizontal number line. We're going to call this horizontal number line X. Boy, would I love it if they would have named this H for horizontal, but they didn't. They named it X. It's the intersection of a horizontal number line called X and a vertical number line, there's the vertical number line, called Y. X is your horizontal, Y is your vertical. And notice that both of those number lines intersect at a perpendicular angle, that means 90 degrees, at where the 0 is on both number lines. Both number lines have a 0, that's where the two intersect. Lastly, they fill in this. In other words, they extend those little tiny tick marks, left and right, up and down, until they get that right there. But you can still see the horizontal and vertical number line. Can you see them? Okay. So I need you to label this. Oh, and also I should have mentioned this at the start of class. I need you guys to have a piece of graph paper. A piece of graph paper. So if you, most of you have them. If you don't, go online. Just Google online graph paper and print you out a copy of a piece of graph paper. Okay. So this is your coordinate plane right here. Notice it has a horizontal number line. We're going to call that the x-axis, and it's labeled X. Most coordinate planes are labeled. Some of them are not. It is a number line. Notice left and right have arrows on them, and there's numbers on that number line. 0 is in the middle. The positive numbers are on the right. The negative numbers are on the left. So that's the x-axis. It's not just one number line, it's two number lines. The second number line is the y-axis. That's what goes up and down, but notice where 0 is. 0 is smack dab in the middle, just like it is on the x-axis. Notice on the y-axis, the positive numbers they go upwards, and the negative numbers go downward. If you want to tilt your head to the left, you'll notice that the y-axis looks exactly like the x-axis. If you tilt your head to the left, then the positive numbers are to your right, and the negative numbers are to your left. Now, tilt your head back normally, you can see that the x-axis is exactly the same. Okay. All right. There's one other point we have to label, and that's smack dab at the center. We call that the origin, or where things start from. Okay. Remember, Rene Descartes measured where things are at from the center. There are three main reasons why we have or use a coordinate plane. The first one, we like pictures. We want to see a visual representation of the data. So a coordinate plane allows you to draw the data and understand the relationship between the data you draw. So for instance, if you had two triangles drawn, you could somehow get an understanding of what's going on simply by looking at the picture. We like pictures. Okay. The second, and probably the more main reason, is it allows us to convert equations to shapes and shapes to equation. Why is that important? Well, think of your cell phone. When your cell phone has a circle on it, how does it draw that circle? I don't want to spoil some of your misconceptions, but there aren't little tiny, I don't know, fairies inside your cell phone that actually draw this, right? There's math equations, and those equations are how the shapes are drawn. Rene Descartes was a pretty smart man. He basically joined two fields of math together: geometry, shapes, and algebra, equations. And he said that shapes are equations. He wasn't the only one that said that, but he was the one that allowed us to visually draw these equations or draw these shapes. All right, and then the last one, the coordinate plane, because there's a number line, it allows you to easily calculate things. You can count little tiny squares, and it tells you, how far distances are. So it allows you to measure the shape relationships. In other words, measure parts of the shape itself. So those are the three main reasons why we use the coordinate plane. We're going to start off really simple, and we're going to end really simple as well, too. The only thing that we're going to graph today are points. Remember the definition of a point. It's a location in space. It has no dimensions. Even though we will draw points with a circle or a filled-in circle, right? A circle is not a point, right? A point is simply indicating a location in space, like where are you? All right. So now believe it or not, that's the easy part. The more complicated part comes in the notation of graphing points. So if you've never seen this before, this is going to be new to you. Those of you that have seen this before, listen and see if you pick up something new. All right, we are going to name the representation of points as an ordered pair. So the mathematical representation or the numerical representation of a point in space is called an ordered pair. When I say ordered pair, I mean a point. When I say a point, I mean an ordered pair. And what an ordered pair allows us to do is to graph that point in its correct position in space. Okay, so there is notation, mathematical notation for this. Here is the mathematical notation for an ordered pair. It starts off with a capital letter. It's italicized. This is called point A. And then you have an open parentheses and a closed parentheses. And between the open and closed will be two numbers separated with a comma. So this is, in math notation, this is point A. And then we have two numbers. Those two numbers represent where is the point on both the x-axis and the y-axis. And luckily for us, they leave them alphabetical. So the first number is where are you on the x-axis? That's the horizontal number line. And the second number, notice it's separated with a comma. The second number is where are you on the y-axis? It's critical that you understand that there are two numbers and they are in a specific order. And the order, hence the name ordered pair, the order goes X, Y. If you mix that up, you will put the point in the wrong location. Okay, so ordered pair, ordered because it goes X, Y. Pair, there are two numbers, 2 and 5. Separate with a comma. Lastly, there is there's the name of the point. That is point A. So now what we're going to do is we're going to graph a point. I'm going to give you an ordered pair. That's the representation of the point. And you're going to graph this sucker. I do want you to remember to always, before you graph, to label your point. Here's what I mean. There's a point, 2, 5. I want you to, above the 2, write an X. And above the 5, I want you to write a Y. You need to do this so you don't flip-flop those numbers together. It's really easy to do. Okay, here's point B. Point B is at negative 2, 5, but the first number is always your X, and the second number is always your Y. When you're first doing this, label is what will keep you from making a silly mistake. All right, let me show you how to label these 2 points. Here's how it's done. So our first point is point A. It's at 2, 5. I said step 1 is to label X, Y. It goes alphabetically. It's nice. Now remember what this means. This means where is the relationship of this point to the origin? That's the center. So we're always going to start at the origin. So you put your pencil at the 0, at the origin, and you simply look at the first number. The first number says 2. 2 is where are you on the horizontal or the x-axis? Well, simply find 2. 2 is, well, 2 units away from 0. But remember, that's left and right. If it was negative, we would go to the left. If it's positive, we go to the right. So we go to 2, left and right. And then the second number tells us how far to go up or down. So what's the second number? It's 5. It's a positive 5. So we go up to positive 5. So not 1, not 2, 3, 4, 5. Where you wind up at 2 to the left, 2 to the right and 5 up is point A. So don't forget to label it. There's point A. Once again, look at that. That's 2 to the right, positive 2, and positive 5 upwards. Right? Kind of got it? Maybe do another one. All right, here's point B. Point B is at negative 1 comma 3. Once again, step 1 is to always label X, Y. We always start at the origin. The first number tells us where we're at, left or right. Notice it's negative 1 this time. So we don't go to positive 1, we go to negative 1. That's where we're at, left or right. The next number tells us how far to go up or down. So it's a positive 3, so we go up 3, 1, 2, 3, and where we wind up is point B. So don't forget to label, there's point B. Making sense? All right, let's do one together. Grab your graph paper. Now notice your graph paper does not have an X or a Y. So you're going to have to, and please don't use the whole sheet of paper, okay? Take a portion of that. You could probably fit 4 or 5 of these on each side of a piece of graph paper. Okay. So let's see. We got to put it, since your graph paper doesn't have an X and Y, we got to put an X and Y. So you make a plus symbol, right? Make sure you go through yours are black, mine are blue. Make sure you go through straight down a blue line, left and right, and then up and down. So the question is, do you need to put numbers? Notice mine has numbers. I would highly recommend that you put some numbers. Maybe count up to 5 and put a positive 5, or count down, put a negative 5. Go to the right, put a positive 5, or go to the left and put a negative 5. If you want to go by 2s, that's pretty good as well too. If you put all the numbers, it becomes very cluttered very quickly and takes you forever. Okay, you can count little squares, right? That's not too hard to do. Now, when I say count squares, I don't mean from the center of the square. I mean, see the little black lines? Yours are blue. I mean, you're counting those little tick, I call them tick marks. They're more formally called stadia line or lattice lines. Okay, so back to graphing point C. Point C is at 3, 4. Remember, step 1, label. So X comma Y, all right? 3 tells us how far to go left or right. So from the origin, we always start at the origin. We're going to go, let's see, positive 3. So that means go to the right 3. 1, 2, 3. And the second number tells us how far to go up or down. It says 4. 4 is positive. So we go up positive 4 spots. 1. Notice I'm not counting from the middle of a square. I'm counting on a black line there. Yours are blue. 1, 2, 3, 4. Where we wind up, right there, is your point C. So don't forget to label. There's point C. Getting the hang of things? All right, let's do another one. Now you can put more than one on the same graph, more than one point on the same graph. All right, so let's do 2 comma negative 4. So point D is at 2 comma negative 4. Let's make sure we label X comma Y. Let's see, X is at positive 2. That's left and right. We do left and right first. So let's see, positive 2 means go to the right 2. If it was negative 2, we'd go to the left 2. And then we got a negative 4. That tells us how far to go up or down. So negative 4 means go down 4. 1, 2. Notice where my dots are. They're on those lines. 1, 2, 3, 4. I don't count the line that I start on. Okay? Okay, so where we wind up, right there, that's point D. So don't forget to label. There's your point D. For those of you that need to see this again, rewind, play it again. For the rest of this, there is 3 points. Make yourself a new graph, right? Take your piece of graph paper, make a new graph, and I want you to label point E, F, and G. Make sure you label them. Go ahead. How'd you do? All right, well, let's see. Point E is at 1 comma 3, so that's X, Y. So that's 1 to the right and 3 up. I wound up right there, and I labeled it E. Point F. Ooh, negative 3, 6. Remember, the first number is your X and your Y, or your X. The second number is your Y. So when X is negative 3, that doesn't mean go to positive 3, left and right. That means go to negative 3. So we go to negative 3, and then what? Up or down 6? Oh, it's positive 6, so we go up to 6. So I went left 3, up 6. Make sense? Oh, forgot to label. Let's label. Last point, G, 7, negative 2. Remember x, y. 7 is positive, so we go right to 7, and then we go down to, there's your point G. Does yours match mine? Good. Cool? You want to see yeah, you. I never know when that's going to end. Oh, there, one more. That's got to be the end. It is. Okay. So are there any difficult ones when you do this? There are. That is when you see any negatives or one, either the x or y, is 0. So remember, if any one of them is a 0, that means you're not moving anywhere for either the x or for the y. So make sure you're careful on that. If it's 0, 3, you're not moving anywhere left or right. You're only moving up and down. If it's 3, 0, you're moving right 3, but you're not moving up or down. So here's 3 more. Go ahead and do these 3, and then pause it, and then check your work. All right, let's see. So the first one, -1, -3, that's left 1, down 3. Left 1, down 3. Because remember, -1 would mean go to the left. -3 on the y mean would go down. So I'm going left 1, down 3. There's point H. Second one, -2, 9. That's left 2 and then up to +9. Because remember, y, +9 means go up. If it was -9, it would mean go down. And the last one, 5, -5, that's right 5 and then down 5. Right 5 and then down 5. That would be right there, and that's your point J. Ooh, you guys are getting this. I said the second one that gives you a problem are when there are zeros involved. So go ahead and try these. How'd you do? All right, so let's see. X, Y, so that means I'm not going anywhere left or right. That's the X at 0. I'm going to stay at 0, and then I'm just going to go down 3. So that's point K. -2 means I'm going to go left 2 and then not go up or down at all because the Y is the 0. So I'm not going up or down at all. So, well, there you are. There's point L. And the last one, 0, 0, the easiest one. Hey, if you don't move anywhere left or right or up and down, you haven't moved anywhere from the origin. You're still at the origin. There's your point M. Guys feeling confident? We need to switch things up. Get it? We need to switch things up. This time I'm going to give you a point. You're going to tell me the coordinates. So can you see that on the screen? Right? That's point W. Where is point W? Remember, any point is an ordered pair. An ordered pair has an X, comma, and a Y. So to do this calculation, you need to first figure out how far are you left or right. So do you see where W is? How far is it left or right? Well, luckily we got some numbers there on our number line. If you have to count little tiny lines, well, then count tiny lines, right? But I can tell that I am 8 to the right, sorry, 8 to the right. So I'm 8 to the right. That's my x value. And how far am I up or down from the origin? Remember, origin is the middle. So it looks like there was no number there, so I need to count 1, 2, 3, 4, 5. I am down 5 from the origin. Remember, when you go down, it's negative. So I'm at 8, -5. Does that make sense? Let's do another. Hey, there's point I. Where's point I? Let's see. Point I. Point I looks to be from the origin, it's to the left. So let's see. It's 7 little tick marks to the left. So that would be -7. Remember, it goes X, Y. So that would be -7. How far up or down? Oh, it's up from the origin. It looks like it's up 5 from the origin. Okay. So that would be -7, 5. Easy or hard? Oh, most of you are saying easy. I agree. So let's do some. Here are 5 points. See the 5 points? Your job is to tell me the coordinates of point J, K, L, M, and N. Go to it. Okay, how'd you do? Let's see. Point J is 1 to the left, so that would be -1, and then 4 up, +4, so -1 comma 4. Point K, the hardest one. Notice it's not left or right anything. So left or right, the x value is 0, but it's down 9 or -9. So 0, -9. Does that make sense? How about L? L is left 3, in other words, -3, down 10, in other words, -10. So -3, -10. Lastly, point N looks to be right. That'd be positive. Right 9. I didn't do M, did I? Sorry. Never mind. Let's do M first. M is right 2, so +2, and up 2, so 2, 2. 2, 2. Lastly, N. There we go. N is right 9, so that would be +9, and down 1, that would be -1. So 9, -1. How many people got all of those right? Good job. Well, ladies and gentlemen, that was it. That's a whole year of math for you right there. Good job paying attention this year. Most of you made some crazy good progress this year. Right? We will continue this progress next year in course 2 in pre-algebra. Try not to let all this information leak out of your ears between now and when I see you again in August. But we'll stop right there. Just remember, next week we're going to do reviews. So the school's not over yet, but me teaching you new stuff is officially over. See you guys on Monday.
Oh yeah. Oh